chapter, we concentrate on each detail. Okay, the first one, we concentrate on how to analyze the continuous time and continuous system first. Okay, the way to analyze, we use the mathematics that you already studied in the first year. Okay, in order to analyze the physical phenomena, the engineering must model these physical phenomena by mathematical equation and then determine the solution of this equation when excited by the input function. Okay? The physical system is usually modeled by the mathematical equation such as the differential equation. This model, okay, the system. Okay, we frequently explain them or describe them or model them by the differential equation. Okay, if we have the input x t, okay, you have the output y t. You can write the equation that link between the input and the output, okay, and the system itself. Okay. Therefore, in this case, if you change the input, you can determine the output before you really create them, okay? Because by the mathematics product, okay, you know how to manipulate them. The physical signal, the signal is, yeah, the signal in this case is xt and the yt is classified as the signal. Okay, the physical signal are usually modeled by the mathematical function. And in this case, you can see that also, okay, all functions and the system xt, yt, and the ht, all of them is depend on only one variable t. In fact, in the general system, it may be depend on more than one parameter. But for simplicity, okay, we will force them to depend on only one parameter's type or t. Okay, in the real case, real situation, okay, the signal or the system may be depend on the displacement that you may be use the coefficients, okay, coordination, okay, x, y, and z, or so on. But in the signal system subjects, okay, we force, okay, we simplify that, okay, every function, every system depend only on type, depend on type t, a single parameters. Okay, the function of the independent variable t. Therefore, in this case, t start is have all value from infinity to infinity. Can be negative, can be positive, can be floating number, rational, irrational number. Okay. Now the next one. Okay. In this chapter, we have about the following topic in here. We have up to 7 topics, but the first 4, the first 5 is based on the signal only. Okay, the transformation of the signal. Okay, discuss, okay, how to manipulate or how to compute the signal in a simple manipulation. Okay, next one is about the characteristic of the signal that may be classified as in this case. Even though the signal have so many characteristics, but we concentrate only on 2. First one is the even and the odd characteristic, and the second one is the periodic of them. Okay. Next one is a common engineering that you can find in the engineering. Okay. Common signal that you can find in the engineering. The signal that frequently found in the engineering is mean the signal or the function that generate from the differential equation. Yeah, the result from the differential equation may be the simple decreasing exponential, may be a little bit oscillate or something like that. Okay, we will explain all signal in here. In the case that if you go to the laboratory, you find that the response that you use the oscilloscope or the meter, you measure the signal. If it have this shape, okay, you know where it came from. It came from the solution of the differential equation. The next one, the fourth topic, is about the singularity function. The singularity function is the function that don't have its derivative in some point. Okay, or it means it don't have the slope value at some point. It means the slope at some point equal to infinity. Okay, the singularity functions play an important role in the advanced signal analysis. Okay, in this class we concentrate only on 2 singularity function: the unit step function and the unit impulse function. Later, okay, if you know the signal in the graphical point of view, how to write them in the mathematics and how to convert the mathematics to the graphical point of view. Because when you would like to integrate them, when you would like to determine the Fourier transform or so on, you must convert the graphical signal into the mathematical function first, unless you cannot integrate them or you cannot determine its transform. Another two topic is about the system, okay? Introduce about the continuous time system and the property of the system. The property of the signal we concentrate only on two, okay? Is the even and the odds characteristic and the periodic, okay? But the property is have up to 6 property for the system that we will discuss later. Now, in this case, we will start by the transformation of the continuous signal first. Okay? The function of the independent variable time xt, yt, or the ht, where t is the all value start from minus infinity to infinity. The function xt can be real or can be complex, but the value time, the variable time t is always real number. The transformation of the continuous time signal can separate in two main groups. The first one is the time transform, and the second one is the amplitude transform. The time transform, we have another three kind of them. The first one is the time reversal, time scaling, and the time shifting. For the amplitude transform, we have another three: amplitude reversal, amplitude scaling, and amplitude shifting. For the time reversal, you can define that if yt is the time reversal of the xt, then in the mathematical definition, yt equal to x minus t. Okay. The functions yt can be created by replacing t with minus t in the original signal xt. Okay. In the graphical point of view process, what about the time reversal? Okay, if the example is here, xt is here, original signal is xt is here. Okay, it's time reversal. It's time reversal is mean you flip or you substitute every t by minus 3, or you flip the xt respect to vertical axis. Yeah, respect to vertical axis. That show you in the slide. You can see that you flip them respect to vertical axis. In the graphical point of view, yt is the mirror image of the original signal xt that is reflected about the vertical axis. The application of the time reversal is the calculation of convolution. Next one, the second time transform is the time scaling. If yt is the time scaling of the xt, then yt is, can write them equal to xat, where a is the real constant, is a real. Okay. In the graphical point of view, yt is the compression or the expansion of the original signal xt, depend on absolute a. For absolute a is greater than 1, the functions yt is compressed in time. As show you in the following example. If xt is the same as the previous one, okay, previous example. Okay, if a, in this case, if a equal to 2, okay, what happened to the signal? If a equal to 2, it means if absolute a is greater than 1, therefore the functions yt or the time scaling will be the compressed version. If it equal to 2, it means you compress the signal at every point by 2. In this case, you can see that, okay, if you see in, okay, the mouse, okay, the okay, the peak, okay, the peak of the signal is at the time equal to 2, it equal to 1. Okay, therefore, when you use the time scaling, you can see that in the time it will be compressed the signal. Therefore, the peak of the signal instead is reached at time equal to 2. No, it's okay, it's scaled by half. It's reached the maximum at time equal to 1. Okay, every point will be compressed, okay, by half. Okay, by 2 times. Or another one case, okay, in the case that absolute a is less than 1. The functions yt is expanded in time. Expanded in time is mean if in this case, if a equal to 0.5, it means that the signal will be expand double. You expand the signal, stretch them, okay? Right, show you in the slide here. Yeah, okay, you can see that you stretch them, okay, double. If, okay, in this case, you can see that the peak of the signal instead is reached at time equal to 2. No, it reached at time equal to 4 instead. Yeah. Next one is the time shifting. If yt is the time shifted of the xt, then yt equal to xt minus t naught, where t naught is the real constant. Okay, the general formula will be right in this format: x equal yt equal to xt minus t naught. Okay, in the graphical point of view, yt is the shifted image of the original signal xt. For t naught will be greater than 0. The function yt is the shift to the right relative to xt. Therefore, in this example, if the original signal is xt, we show you in this figure, yt, okay, yt in this case equal to t minus 2. Checking from the general form of them, okay, t minus t naught. Therefore, in this case, t naught equal to 2. Yes, if t naught equal to 2, it means t naught is positive. If t naught is positive, the function yt will be shifted in the right hand side. We see that it will be shifted in the right hand side by 2. Okay. In another case, if t naught is negative, the function's yt is the shift to the relatives to xt instead. Therefore, if yt equal to xt plus 1, if t plus 1, you compare from the original signal, okay, xt minus t naught. In this case, t naught equal to minus 1. If t naught equal to minus 1, it means you shift in the left hand side instead. Shift by 1. Shift by 1. And this thing is the result of the time shifting when t is negative. Okay. In the case that if you must process 3 transform in the same time, okay, in this case, determine the second time transform of the signal yt is here, where xt will be shown you in this figure. Okay, minus here, minus is represent for time reversal. 0.5 is represent for time scaling, plus 1 is represent for time shifting. Okay, you must take, okay, reversal, scaling, and the shifting. The key for the take the time transform, which step you should take first. Okay, in this case, we must take the time shifting first, and then you take time scaling and the time reversal after that. Okay, for the time shifting, in this case, you shift by plus 1. You shift by plus 1 is mean plus 1. Plus 1 is if you compare from the original form, okay, n naught, t naught equal to minus 1. If t naught equal to minus 1, it means you shift in the left hand side. Okay, you shift in the left hand side by 1. Okay, give you here xt plus 1. Okay, you already take process for the time shifting. Next step, you take time scaling. You scale by 0.5. In this case, if you scale by 0.5, it means you must expand the signal double. Okay, expand the signal double. Okay, you expand the signal respect to vertical axis. Okay, vertical axis. Okay, give you x here, 0.5 represent for time scaling. Last one it take for the time reversal. Minus is take for time reversal. You flip the signal respect to vertical axis. Okay, this thing. This is the result of all 3 transforms in a single framework. Next step is the amplitude reversal. If yt is the amplitude reversal of the xt, then you can write yt equal to minus xt. See that? Minus is here, minus, okay? Minus is in front of x, not in front of t, okay? For the time reversal, minus is in front of t, okay? But the amplitude reversal, minus is in front of x, okay? The functions yt can be created by reversing the original signal xt, okay? Reversing the original signal xt. You may be seen to flip the signal, but flip respect to horizontal axis. You see that? Negative, flip them to be positive. Positive, okay? Flip them to be negative. Okay. In the graphical point of view, yt is the mirror image of the original signal xt that is reflected about the horizontal axis. If yt is the amplitude scaling of the xt, then yt equal to a xt. A is the real constant. You see that? In this case, a is multiplied in front of x again, not in front of a, t. Okay, the graphical point of view yt is the compression or the expansion of the original signal xt in the vertical axis depend on absolute a. In the case that if a is positive, the functions yt is expand in amplitude. Okay, okay. We don't care. Okay, it means if a is greater than 1. Sorry, if a is greater than 1, it will be expand. Okay, for example, if a is equal to 2, okay, if a equal to 2, you expand the signal at every point by 2. Okay, you can see that at this place it should to be -1. When you expand them, give you -2. Okay, and the peak of this rectangle, okay, is reached as time, okay, at when t equal to 0, t equal to 2, it equal to 1. Okay, its peak, okay, will be increased to be 2 instead. For another case, if a is between 0 and 1, okay, if absolute a is less than 1, the functions yt is compressed in amplitude instead. For example, if a equal to 0.5, it means you compress the signal in the amplitude point of view, or you attenuate the signal. The thing, okay, the application of the amplitude scaling is more, I think you see them more, the time scaling or time reversal. Okay, because the amplitude scaling you already use when you use your mobile phone or you turn on the radio. Okay, when if the sound is too loud, okay, you maybe attenuate the sound. Okay, multiply them by 0.5 or 0.1 or so on, attenuate the amplifier. Okay, but in another case, if the sound from the radio is too dim, okay, you maybe amplify them, increase them. Okay, you will be, if you set a to be greater than 1, to amplify the signal, okay, to make the thing that you can listen. Okay, the amplitude shifting. Okay, the next one is the amplitude shifting. If yt is the amplitude shifting of xt, then yt equal to xt plus b, where b is the real constant. In the graphical point of view, yt is the shift image of the original signal xt in the vertical direction. For b is positive. The functions yt is the shift to the upper relative to xt. Okay, amplitude shifting, you shift the graph up. Okay, upper compared for the previous one. Okay, now in this case, the if yt is equal to, you can say that if yt is equal to xt plus 1. If x3 plus 1, you mean you add every point in xt by 1. You shift the graph up to 1 position. Okay. But in another case, if b is negative. If b is negative, the functions yt is the shift to be lower relative to xt. In this case, if you yt equal to xt minus 2. If minus 2 is mean you push the signal down or by 2, okay, be lower than the previous one by 2 point every here. If it used to be 0, it equal to minus 2. If it used to be minus 1, it equal to minus 3. Okay. In this case, the same as the previous. Okay. If you must take 3 transform, if you must take the amplitude reversal, amplitude shifting, and amplitude scaling in the single framework. Okay, which step we take first? Minus, okay, minus represent for amplitude reversal. 3 represent for amplitude scaling, and plus 1 is represent for amplitude shifting. Okay, for the amplitude transform, the signal must be amplitude scaling first. You take scaling first, and you take the reversal and the shifting after that. Okay, scaling in this case, you scale by 3. You see that you scale by 3. It means you multiply every point of the signal by 3. If it used to be 0, it equal to 0. If it used to be 1, 1 multiplied 3 give you 3. Okay, and so on. This means yt equal to 3x3 will be show you in the slide. Okay, you expand the signal. Okay, you amplify the signal. Next step, you take the time reversal. Sorry, you take the amplitude reversal. The amplitude reversal is you take them, process them by you flip. Okay, you flip the signal respect to horizontal axis. Yeah, show you in here. After that, you take amplitude transform or amplitude shifting. The amplitude shifting in the last step, you plus by 1. Plus 1 is mean you shift the signal up by 1. Up by 1 at every point. Okay. In a more complicated case, okay, if you must take time and you must take amplitude process, okay, transform in the same framework, which step we take first, time first or amplitude first, okay? For this case, we can summarize that you must take the amplitude transform first and then you take the time transform after that. For the amplitude transform, you must take scaling first, okay? Scaling, in this case, you scale by 3. You expand the signal by 3, amplify the signal by 3 first, okay? It have no reversal, you script them, okay? And you have -1. You take the amplitude shifting by -1. -1, it means you put down by 1. You put down by 1. Okay? After you complete amplitude transform, the next step you take time transform. For the time transform, okay, you must take, okay, time shifting first. In this case, time shifting you shift by +1, right? +1. Therefore, T0 equal to -1. If it equal to -1, T0 equal to -1, you shift in the left hand side. You shift in the left hand side by 1 position. Okay. After that, you take, okay, times scaling. You scale by 0.5. It means you expand the signal by double. Okay, expand, you shred them. Okay, and after that, you take the time reversal in the final step. Time reversal is mean you flip respect to vertical axis. Okay, this is the result of the time transform. Okay, and the one last thing. Okay, in the case that in the previous I teach you, okay, 6 transform. Okay, time transform 3, amplitude transform another 3. Okay, for the time transform, we have time reversal, time shifting, and time scaling. Okay, for the amplitude, we have amplitude reversal, amplitude shifting, and the amplitude scaling. Okay, the next one is, okay, I think everyone know how to multiply the data. Okay, but some of you not familiar to multiply the data in the graphical point of view. Okay. Therefore, I will show you some example. If xt is here, the graph will be show you in the red graph, okay? And x1 is red graph, x2 is the green one, okay? You multiply them in this case for time less than 0. The green equal to 0, the green equal to 0. 0 multiply anything give you 0, okay? Therefore, for okay, for time less than 0, if you multiply them, the result is equal to 0. For time greater than 0, the green equal to 1. 1 multiply anything, give you that thing. Okay, therefore give you the original red graph for the right hand side. But for the left hand side, everything go to 0. Okay. Here they did the example of a graphical multiplication technique. Okay. It's your turn. Okay. Let's do 2.1, okay, and 2.2. Can you hear me?
Yes.
Okay, everyone have the book, right? Hello, can you hear me? Okay, everyone have the book. Okay, take the exercise 2.1 and 2.2, and now I will checking the attendance. Open the camera to checking the attendance.
อาจารย์ครับ
อืม
หนังสือนี่ซื้อที่ไหนนะครับ
อ่ะส่งไปให้แล้วไม่ใช่เหรอ
อ๋ออาจารย์ส่งแล้วครับโทษครับ
Oh, hello, Jimma.
Hello, sir.
Huh? You register the DSP, right?
Yes.
You already passed the signal or not?
No, not yet, sir.
Not yet. It means you which grade you get?
Yes.
Which grade you get?
Sorry, what?
What your grade for the signal before?
No, I don't take.
Never take it before.
No.
Is the DSP is required you must pass the signal system first. It's not allow you to register the DSP without the requirement.
I know, sir, but like my advisor says it's okay.
Huh? Who
My
is your
advisor
advisor?
No.
Sir, who is your advisor?
Anand, sir.
Anand?
Yes.
Which year you are? Second year, third year, fourth year?
Third year, first semester, sir.
Huh?
Third year already, sir.
Third year already? Okay.
Yes.
This is the first time you register the signal system?
Yes, sir.
And you don't register the signal and system yet, and you take the DSP immediately in the same time?
Yes.
Okay. Okay. It's okay. ธนพัฒน์เพิ่งตื่นเหรอเลยจำไม่ได้ว่าอาจารย์ให้หนังสือไปแล้วฮะ ให้ทาง
ให้ไปซื้อใช่ไหมครับ หรือว่าอะไรครับ
ไม่ใช่ ส่งทางนี่ไง ส่งทางไอ้นี่ให้แล้ว ส่งทางไอ้ meeting chat อ่ะเพิ่งเข้าครั้งแรกเหรอ
เมื่อวานน่าจะเข้าล่าสุด
วัน
เข้าล่าสุดเมื่อ
วันอังคารป่ะ
อังคารครับ แต่ว่าผมอาจจะไม่ดูแชทครับ
อ้าวไปดูใน meeting chat น่าจะยังค้างอยู่ใน meeting chat นะ ไม่แน่ใจ เนี่ยผมส่งให้ทั้งคอร์สเอาไลน์เลย แล้วก็ทั้งไอตัวหนังสือให้ลองไปดูเปิดใน Microsoft Teams นะ เปิดอยู่ในไฟล์มั้งใช่ไหมใน document ใน general มันจะมีไฟล์ให้อยู่ PDF 2 ไฟล์
ครับผม คือผมโหลดแค่เอา
คอร์สเอาไลน์
มาครับ
คอร์สเอาไลน์ยังไม่ค่อยสำคัญหนังสือมันสำคัญกว่านั้นเยอะ
โหลดแล้วครับ
มันจะได้มีโจทย์ทำมันจะได้ดูตัวอย่างโจทย์ได้Okay, I go to drink a little bit. Okay, I will come back in 1 minute. Okay. Okay, if you already finished, you can send to me the meeting chat. Okay, maybe personal or maybe in the global, depend on you.
อาจารย์ครับทำเสร็จแล้วส่งในแชทอาจารย์เลยใช่ไหมครับ
ใช่ครับ ส่งมาเลย
ครับ
เดี๋ยวจะได้เฉลยให้
โอเคครับ
No one finished yet? Is have only one is submitted.
ผมทำผิดนะครับเดี๋ยวผมกำลังแก้ไขอยู่ครับ
Oh, okay. I give you another 2 minutes, okay, and I will provide your solution, and we will continue to the next part. Okay. I give you up to about the 20 minutes. Okay. If you're not finished, okay, try to do by yourself. The midterm maybe ask you about, okay, how to determine the time transform like that. But the signal is maybe a little bit more complicated, and the process may be a little bit more complicated than this. Okay. Can you hear me?
Yes, I can.
Okay. Okay, I will provide your guideline. Okay, but if you're not finished, okay, you can record this guideline first. Okay, and try to do by yourself and recheck them after you really finish them. Okay. The first one is, okay, the first sub question is, okay, yt equal to x minus t. It means this question asks you to determine about the time reversal. Okay, the time reversal is very simple. Okay, in the graphical point of view, yt equal to x minus t is the mirror image of the original signal xt that is reflected about the vertical axis, as shown you in this picture. Yeah. Okay, you flip the signal respect to vertical axis. The second sub question is here, minus t and divide by 3. Okay, minus is represent for time reversal. Divide by 3 is represent for time scaling. Okay, in the graphical point of view, you must text about the time scaling first. Okay, yt equal to xat is the compression or the expansion of the original signal xt depend on absolute a. In this case, absolute a is less than 1. It equal to 1 by t. Therefore, the functions yt will be expand for this case. It expand 3 times. You can see that the peak of this signal will be reached at time equal to 3 seconds. It equal to 1. Okay. Therefore, you expand. Okay. You expand them. Okay, 3 times. It reached to 9 about that. About this point. Okay. In the graphical point, the next step, after you determine the expansion version completely, the next step you take the time reversal. In the graphical point of view, yt is equal to x minus t is the mirror image of the original signal xt that is the reflected about the vertical axis as shown you in the slide. Okay, in these pictures. Okay, you flip respect to vertical axis. This is the result of the yt equal to x minus t divided by 3. Okay. The third sub question is here. Okay. xt plus 3. Plus 3. You know that this thing, okay, this operator is for the time shifting. In the graphical point of view, yt equal to xt minus t naught is the shifted image of the original signal xt. But in this case, in the form is t minus t naught. Therefore, in this case, t naught is minus 3. If t naught equal to minus 3, it means the signal will be shifted in the left-hand side by 3 position. Okay, by 3 position, as show you in this picture. Next one, okay, yt equal to minus t plus 2. Minus 3 plus 2 is mean minus is represent for the it represent for time reversal. Plus 2 is represent for time shifting. If you have both of them, you must take time shifting first. In the graphical point of view, yt equal to xt minus t naught, and in this case, is the left shift image of the original signal xt for the case that t naught less than 0 or t naught is negative. In this case, t naught equal to minus 2 is negative. You shift in the left hand side by 2 points. Okay, by 2 points. And after that, when you take the time transform in the next step, okay, you take the time transform respect to vertical axis. Vertical axis. Flip them in the vertical axis. In the graphical point of view, its time reversal is the mirror image of the original signal xt that is reflected about the vertical axis. Okay, for the second question. The second question is transform. Okay, 4 is for yt equal to 4x minus 2. 4 is represent for amplitude scaling. Minus 2 is represent for amplitude shifting. For this case, you must take the amplitude scaling first. Okay. In the graphical point of view, yt equal to axt is the compression or the expansion of the original signal xt in the vertical axis, depend on absolute a. And for this case, is a is in this case absolute a is greater than 1. If absolute a is greater than 1, the functions yt is expanded in amplitude. Okay, due to the limit of the display, okay, space. Therefore, I will change the axis from 1. เน็ตมันข้างล่างมันไม่ค่อยดีsorry can you hear me my internet is interrupt a little bit
Yes, sir, John, we can hear.
okay can we continue okay can you see my slide
Yes.
okay okay after you expand them by the amplitude scaling by 4 okay next step you take okay amplitude shifting you shifting by in this case shifting by 2 minus 2 okay in the graphical point of view yt equal to x plus b is the shifted image of the original signal xt in the vertical direction but in this case b is negative if b is negative you push them down you put them below the original signal by 2 okay next one is the same as the previous okay yt equal to 2xt plus 2 okay it have both the time the amplitude scaling and the amplitude shifting you must take the amplitude scaling first in the graphical point of view okay yt equal to 2xt is the compressed or the expanded version of the original signal xt in the vertical axis depend on absolute a in this case a equal to 2 therefore a greater than 1 the functions yt is the expand in amplitude okay we expand the signal by change this okay the scale of the axis from 1 to 2 okay and next one you shift the signal by 2 points okay shift b equal to plus 2 okay in the graphical point of view yt equal to x plus b is the shifted image of the original signal xt in the vertical direction okay by 2 points next one is the same as the previous again okay yt equal to minus 4x plus 2 okay it have both so it's have more okay 4 is represent for amplitude scaling minus represent for amplitude reversal and plus 2 is represent for amplitude shifting if we have all three amplitude transform you must take the amplitude scaling first in the graphical point of view yt equal to ax sorry yt equal to axt is the compress or the expand of the original signals xt in the vertical axis depend on absolute a for this case okay absolute a is greater than 1 therefore the functions yt is the expand in amplitude in the graphical point of view yt equal to minus xt is the mirror image of the original signal xt that is reflected about the horizontal axis in the graphical point of view yt equal to xt plus b plus in this case b equal to plus 2 you shift every point in the signal by up to 2 okay and the result will be show you in there okay you can see that if the signal choose to be 0 now it will become 2 it will become 2 at every point for the last one is a little bit more complicated than the previous okay 2 is represent for amplitude scaling okay the second 2 is represent for time scaling and the last one 2 is represent for amplitude shifting if you must take both amplitude transform and time transform you must take amplitude transform first okay for the amplitude time and amplitude transform the signal must be amplitude transform first and then time transform later in the graphical point of view yt equal to axt we must take for the amplitude scaling first okay in the graphical point of view yt equal to axt is the compression or the expansion of the original signal xt in the vertical axis depend on absolute a and in this case a equal to 2 therefore for absolute a that greater than 1 the functions y is expand in the amplitude okay we change the scale again okay from 1 to be 2 okay change the scale and the next step we take amplitude shifting you shifting by 2 in the graphical point of view yt equal to xt plus b is the shifted image of the original signal xt in the vertical direction in the upper okay because okay b is positive and the last one we take okay we take the time scaling And in this case, in the graphical point of view, yt equal to xat is the compressed or the expansion of the original signal xt depend on absolute a. But in this case, a is less than 1. Then the functions yt will be compressed instead. Sorry. Okay. Oh, greater than 1. Sorry. A little bit error in here. Greater than 1 is here. Ah, okay. I will check it. Okay. Okay, sorry. If absolute A is greater than 1, the functions yt will be compressed. Compressed. Sorry. Yeah. Ah, okay. Sorry. Due to a little bit typing error in the slide. Okay. 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 In this case, A equal to 2. Okay. A equal to 2. Therefore, for A is greater than 1, the functions yt will be compressed. Okay. In time. Okay. That's all for the exercise that I give it to you. If you can do by yourself and if the result is right, okay, you will know, okay, the right thing to do. Okay. Huh? Okay. We go to the last part. Can you hear me?
Yes, Ajahn.
Okay. The last part is the signal characteristic. Okay. The signal characteristics for this case. Okay. We have, okay, the even and the odd signal. Okay. The function is the even or the symmetry if we can state that xt equal to x minus t. Okay. The even function have the symmetry with respect to vertical axis. Okay. In the graphical point of view, xt for the time less than 0 is the mirror image of the signal xt for the time greater than 0. It means you can see that the signal equal to it. What about the transform? Time reversal. The signal equal to its time reversal. It means you must compute the time reversal first. And if the result is identical to the original one, the signal is there to be symmetry or it seems to be even. Okay. Yeah. If the signal xt is here, okay, you determine its time reversal. The time reversal is mean you flip respect to vertical axis. Flip them, give you here. You can see that the okay, its time reversal is already identical to the original signal. Give you here. Okay. Therefore, we can conclude that the signal is even signal. Okay. For example, the cos function is the even signal because the cos omega t equal to cos minus omega t. But the sine omega t is not the even function because sine omega t is not equal to sine minus omega t. Okay. Next one, the odd function. Okay. The function can be called the function is an odd symmetry if the function equal to xt equal to minus x and minus t. It means the signal equal to its amplitude and time reversal. The odd function have the symmetry with respect to original point. Okay. And in the graphical point of view, xt for time greater than 0 is a mirror image of the original signal xt for time greater than 0. You can see that you see them to be the symmetry with respect to original point. Okay. How to checking that the signal is odd or not? Okay. You will proceed for the time and the amplitude reversal. Okay. ไปเรามาเปิดสาย Sorry that okay my daughters walk to pick some item. Yeah, to interrupt about this. Okay, yeah. Okay, now we came back to the odd function. Okay, the odd function, if you would like to check that this signal is an odd function or not, okay, you can check by process the time and amplitude reversal. If you must proceed for the time and the amplitude transform, you must proceed for amplitude transform first. Okay, determine the amplitude reversal first, and here this version is amplitude reversal. You flip the signal with respect to horizontal axis. Okay, flip them. This is the amplitude reversal. The next step, you determine the time reversal of the result. We will give you here. If the result of the signal is identical to the original one, we can conclude that that signal is the odd. Yeah. And in this case, the sine omega t is the odd function because the sine omega t equal to minus sine minus omega t. Okay, you can show that. Okay, now in another one thing more. Okay, a signal xt can be mathematically expressed as the sum of the even part and the odd part, because sometimes the signal xt, partial of them is content of the even part, partial of them is content of the odd part. It's not purely even or it's not purely odd. Okay, therefore in this section we try to extract how the even part and the odd part of the signal. Okay, from the above equation, the even part of the signal xt can be determined by this equation. It means the even part of the signal you can determine from the original signal add with its time reversal and use the amplitude scaling by half. Okay, for another part is from the above equation, the odd part of the signal xt can be determined by the same. Okay, the original signal subtract with its time reversal and use scaling by half. Yeah. The average of ax of the signal is here. Xt can be defined as the following, okay, equation. Okay, and the average value of the signal xt is containing only on the even part because the average of the odd part is the 0. Okay, and the next one is the property of the even part and the odd part of the signal. The sum of the two even function is even, and the sum of the two odd function is odd. Okay, the sum of the even function and the odd function is neither even nor odd. The product of the two even function is the even, and the product of the two odd function is the even too. And the last one, the product of the even and the odd is become odd. Okay, if you know about, okay, if you can remember about this property, it can facilitate your integration in the Fourier transform or the Laplace transform so much. Okay, I will explain them later why. Okay, next one. Yeah, in order to demonstrate about this, okay, how to determine the even part and the odd part of the signal. Okay, determine and sketch even part and the odd part of the signal xt, where xt is shown in this figure. Okay, xt is here. In order to determine, okay, the even part and the odd part, okay, you must determine okay, you must determine the time reversal first. Okay, the time reversal is a green signal. Okay, and after that you adding between two clock together. Okay, when you adding them, okay, okay, do step by step. Okay, you add each piece of this clock. Okay, you sketch both graph in the same axis first. Okay, in the same axis. Okay, now in here, okay, you can cut the signal in each piece. Okay, in each piece. Okay, the first one is here. If it less than -2, everything is 0. 0 as 0 give you 0. Okay, 0 as 0 give you 0. You can see that the result. Okay, and if 1 and 1 is here. If you're not sure, okay, When you adding them, you shift them in the left hand and right hand a little bit one. Okay, I will show you in the. Okay, wait a minute. Yeah, can you see my whiteboard?
Yes, อาจารย์
เห็นแล้วครับ
Okay.
Yes, Susan.
Okay, I use the micro. I use the mouse. Okay. Okay. Therefore, it's two. Sorry. Okay. That's one. That's two. Okay. Okay. Yeah. Okay. The green one is here. Green one is okay. Can you see the whiteboard, right? Okay. I will show the computation only in the left hand side. Okay, some part of them. Okay, you cut the signal in each piece first. Each piece. Okay, yeah. Okay, and you consider them only in this. Okay, in this area, in each piece. Okay, the first one. Okay, at this point. Okay.
Sorry, teacher. For me, it's just shows like it's loading.
Sir, hello.
The whiteboard, it's just showing like it's loading. I cannot see the things you write.
Oh, really?
I don't know if it's only me or other people.
มีใครเห็นไวบอร์ดไหมหรือไม่เห็น
เห็นครับอาจารย์เห็นครับ
Oh, your friend is can see the whiteboard. What happened to you?
Maybe something wrong with me. I'll leave the call and come back again.
I don't know. Okay, you must fix the problem. I don't know. Okay, here you can see that in this case. Okay, in this case. Okay, for example, you would like to find the result. Okay, when you adding the graph. I think everyone know how to adding the data, right? But the way to adding the graph sometimes is not easy. For example, when t equal to 2, you can see that t equal to 2, the red graph is easy. Okay, the red graph is okay equal to minus 3 at this 0 at this point and 0 at this point too. Okay, you don't know that. Okay, at this point. Okay, is okay at time equal to 2, at time equal to minus 2. Sorry, at time equal to minus 2. Okay, in this. Okay, the red one is okay, is 0, right? It's 0, it's easy. But the green one is not. The green one when t equal to 0, t equal to minus 3, it equal to 0. But when 3 equal to minus 2, it may be 0 or it may be 1, right? It may be 0 or it may be 1. Okay, it's 0 or 1. Okay, you consider in only in this area. Okay, and shift them a little bit. Okay, in this case, you shift in the left hand a little bit. Therefore, you get this point. You get this point. If you get this point, you get this point, and you get this point. Okay, if you get here, therefore you can conclude that you must choose 0, right? You must choose 0. Okay, the green is a 0. Okay, the first point of the green is a 0, and the last point of the green is a 0 too. Okay, therefore the result of this graph, equal to 0 as 0 give you 0, right? 0. Okay, and 0 as 0 give you 0. Can you see that? Where I came from? You can plot that. Okay, 0 and 0 give you 0. Okay. Now we add them in the second place. Okay, second location. Okay, the first place, first region. Okay, the second region is here. Okay, now the red one is still 0 in this point, and at this point, you know that you must shift them a little bit 1. Okay, shift them here. Okay, the red one in this case, okay, is 0. Okay, it have no problem. But the red one, when time equal to -1, when time equal to -1, it may be 0 or it may be 1, right? It may be 1, but you know that you cannot choose 1. Okay, you shift them in the left hand a little bit for inside this section. Okay, therefore it will become 0. 2 point of them is 0. Start point and the last point. Okay, the next one, the green, when okay, it may be equal to 1, 0 or 1, right? At time equal to -2. Okay, but you know that you shift them in this area, therefore it must be 1 at this point. Okay, at this point 1. Okay, and the next point is still 1, 2. Okay, you add them. 1 as 0 give you 1 as 0 give you 1. 1 as 0 give you 1. Therefore, the result of this case is 1 and 1. Okay. Like this. Okay. Now, the last section is the section 3. Section 3 is here. Okay. The red curve we use the inside here. Okay. It's 1 and it's 1. Where it came from is 1 and it's 1. Okay. The green at this point, the green is 1, right? At this point, it's equal to 1, and this point is close to 0. Okay, 1 and 0. Okay, you adding them. Okay, you adding them. 1 add 1 give you 2. Okay, and 1 add 0 give you 1. Okay, now when the point equal to 2, where it is? 2 is about here, right? 2 is about here, and 1 is about here. Therefore, the graph will be here. Now, what about the result? Yes, okay. The result. Oh, sorry. Delete entire graph. Okay. Therefore, the result of this graph will be here. Okay. You get each piece of them. It's a 0, it's a 1, and it's here. Okay. You ring between them. Okay. In order to make you more understand, okay, ring between this graph here, 2 graph, ring between 2 graph. Therefore, the overall of this graph will be show you in the right hand side in each step. Okay, try to trace by yourself. Okay, you can see that when you adding them, it's not difficult, but it's easy to confuse. Okay, I will go to the main slide again. Okay. Okay. Can you see my slide? My main slide, my main PowerPoint? Hello? Can you hear me?
Yes, Sachin.
Okay.
Yes.
Can you see the slide, right? The slide, the PowerPoint slide?
Yes.
Okay.
อาจารย์
Huh?
sorry I have neck card ครับ Can I read?
Okay. I will re-explain them again in the next time. Okay, time is due. Okay. Okay. See you again and take the exercise. Okay, in the next time. The homework is the question number 3 and the question number 4. Okay. Okay, do another 2 more. Okay. Okay. For this class is dismissed. Okay. Good luck. See you next time.
โอเคครับ
สวัสดีครับ
Thank you, Ajahn.
You're welcome.
Goodbye, Sean.
Goodbye.
Thank you อาจารย์
Thank you, Sachin.
อาจารย์ครับพาร์ทเวิร์กที่ต้องส่งอาจารย์